Today on MatHAMMatics, we will be looking at how to graph quadratics through the lens of transformation. Now, in our previous unit, you may remember that we looked at transforming functions from their parent, parents being the most basic form of any function. And for a quadratic, the parent function is f of x equals x squared. Now, parabolas, unlike other functions that we have graphed, require at least 5 points, including the vertex, to accurately sketch. And so to start, let's list the 5 basic parent points. Of course, the most basic of the parent points is going to be when x is equal to 0. We can plug 0 in. 0 squared, of course, is 0, and we can plot the new point. So we have a vertex right there at the origin. Now, of course, we can then plug in simple points to square. 1 squared, for example, is 1. And we know that because of the symmetry that exists in quadratics, -1 would also yield an upright 1. We could plug in 2. 2 squared, of course, is 4. And using symmetry, we can see that -2 would also give us 4. And so these are widely considered the 5 basic parent points. Now, like in other functions that we have transformed, you can use any parent point you like, so long as you keep the vertex intact. Sometimes it's helpful to shift up your parent points if you need to work with different fractional transformations, so that you end up with nice integer points to plot. Sketching the curve through our points, then, we have our parent function. So let's look at example 3 here on our notes. Remember, when we see that -3 inside the set of parentheses acting on x, that means that we are actually doing the opposite. We are going right 3, or the function is being shifted 3 units to the right. That 4 on the outside of the set of parentheses, that's an impact on the vertical change. It's a shift down of 4. So remember, we can write the point mapping rules. Our x values are going to increase by 3. Our y values are going to decrease by 4. Plugging in all of our 5 original parent points, we can then get our new set of points to graph, plot them, and draw the curve. If we take example 5, remember that x plus 2 really means that we are going to be moving left 2 units. That 1/4 on the outside is a vertical compression, or a multiplier on the y. The -1 on the outside, of course, is a down 1 shift. Because we have a vertical compression by the factor of 1/4, remember that you can use multiples of 4 in your parent point selection. This will help you avoid fractional points. If you consider a problem like number 15, that the first thing you want to do when you have a coefficient on x is to factor the inside. What that allows you to do is see what the true horizontal stretch or compression is, as well as the true horizontal shift. Notice then we have a compression. Remember that that multiplier of 3 becomes a compression of 1/3, or our x values are multiplied by 1/3, or divided by 3. We then have a shift to the right of 2 units. On the outside, that negative indicates a vertical reflection. Our y values are turned opposite. From there, you shift up 7 units. Again, you may always have the option to choose parent points, in this case, multiples of 3, that could help you avoid graphing fractional points. So quadratic transformations operate much in the same way that the absolute value transformations did, with, of course, the major difference being the parent function. Transformations that occur to x are opposite operations, whereas transformations on y carry the same operation. So the practice for tonight is to complete the remaining transformations in this packet.